This problem says, standing at the top of the Clos Commons, you throw your textbook into the air, giving it an initial momentum, p initial equals 2050 0 at time t equals 0. Sometime later it lands on the ground a vertical distance of 20 meters below. On the graphs below, sketch the x component and the y component for the momentum of the textbook during its complete flight as a function of time. The only force acting on the textbook is due to gravity, pointing in the negative y direction. So for this problem, you have to graph the momentum in the x and y directions. For the x direction, I got this on the test, because there's no force acting on the textbook in the x direction, so momentum in the x direction stays constant, starting at 20, which is given to you in the problem. However, when I got to the y direction on the test, I started thinking in terms of position, thinking the textbook goes up and then heads back down and reaches 0 at the end. However, the momentum does start at 50, which is given to you in the problem. The y component is 50. However, it starts at 50 and has an initial y momentum upwards. However, it's slowing down because the force of gravity is acting in the negative direction. So, it does start here, but it starts going downward till it reaches a velocity of 0. Or velocity is proportional to momentum, so it reaches a momentum of 0. However, once it reaches 0, then it starts going in the negative direction. The textbook starts heading down, and it goes all the way down until the time stops. So it's going up in the positive direction, but it's slowing down till it reaches a momentum of 0. Then it changes direction, so the momentum is now in a negative direction.